Good afternoon, everyone. We're going to be talking about the energy crisis that we are going to be going through here in the next future. But we predominantly use in the United States to produce energy is through fossil fuels, natural gases and stuff to produce the electricity that we use to provide energy to our homes. But the problem with that is that they're really harmful on the environment. They create lots of greenhouse gases and are really bad for our planet and the climate. And also, those resources that we are using are dwindling very fast. So we got to look for solutions and what to convert to, so we can reach up to the demand of the energy that we need. And a lot of people are talking about wind and solar energy, but here's why people don't understand that those aren't going to be as successful as other options that are out there. And predominantly what we're going to be talking about today is nuclear energy and why we need to really consider switching up to it. Now, let's start off with pollution. Solar pollution, it doesn't make any gases, but in the production of these large-scale solar panels that we need to make, they are really made with harsh chemicals that are very potentially risk to the biosphere of our planet. Another thing is that they take up lots of space, that take away lots of area from our farmers and agriculture people, and they have to have all that space to produce enough energy to provide energy for homes, just at the scale that fossil fuels would. So that right there, we're taking a big portion out of one chunk of our economy and everything that makes our world work, and we're taking it to energy. It's not really that beneficial, and that is those terms are brought up to by the Union of Concerned Scientists. Now, wind pollution. Wind pollution, it has almost zero emissions, but according to EIA.gov, a lot of the carbon footprint that comes out of the wind production would be like the production of the windmills itself, because it takes a lot of fossil fuels to melt those down, because windmills aren't just like a 10-foot tall structure. No, they're huge monuments that they spin so they can produce a lot of energy. And a lot of more problems with wind energy would be it impacts a lot of the natural environment around it. Not just like in terms of gases and stuff, but animals. It kills lots of birds, and there's a lot of noise pollution that comes from the spinning of that huge turbine, and it bothers a lot of wildlife. Let's go on to the fact of nuclear pollution here. Now, according to William Eubanks, a lot of people think of nuclear waste as like a green ooze that's radioactive and kills everything in its path. That's not true at all. Okay? It is very toxic and harmful, but when disposed of properly, it's very safe for everyone. Right here, in this little diagram that I made, as you can see, we got our little nuclear reactor plant, and we essentially bury all the nuclear waste 5,000 meters underground. Now, how they do this is they do a long tunnel, and they have branches off. And right here, they have these little tunnels with little twigs off of them. And in these twigs right here, they have a big canister, and that is what they use to store the nuclear waste in whenever it's all used up. Now, like in terms of how it's sealed, it is naturally sealed in the bedrock that is in our crust, and there's very little groundwater that is used to go back up into our biosphere. So the groundwater that is around this is very minimal and is not to the point where it's recycled into our biosphere here. And also, 90% of the waste that comes from nuclear energy is recycled back into the plant, so we can further get as much as we can out of the fuel in the nuclear facility. Now let's talk about the efficiency of renewable energy and non-renewable energy. Now, renewable energy is very useful. It doesn't rely on a finite source of fuel to achieve maximum energy potential. But they aren't efficient enough to be at the large scales that we have in our coal and natural gas plants. And a lot of them are geographically bound. So that means like in places like hydroelectric power and geothermal power, you need specific conditions. Like in hydroelectric power, you want to be along a river, a hard-flowing river, to spin a turbine to produce a lot of energy for cities, homes, and all that. Geothermal energy is big in Iceland, where they're really fortunate enough to have places where there's a lot of underground heat that they can use to produce energy for their houses. Solar and wind also have an issue that when the sun's not shining and the wind's not blowing, it's going to be really difficult to produce energy from. And you could make the argument that, well, you use batteries to store this energy. Well, batteries are going to be becoming a very difficult place to try to achieve success in, because you got new markets such as like electric cars that are using energy, and they don't last forever as much too. Wind energy is also better used in flat areas. So like the Great Plains, not Rocky Mountains and stuff like that. It's better in the Great Plains, not in a mountainous area like Appalachia or the Great Rocky Mountains, such as that. Non-renewable energy provides consistent energy around the clock, so you don't have to worry about where it's coming from. So you don't have to worry about if nature is going to be an influence in where it's coming from. It's very harsh on the environment, though, and just carbon emissions and greenhouse gases are heating the planet, and it's not going to be very sustainable for much longer, too. But nuclear energy, it's a non-renewable source of energy, but it doesn't create the greenhouse gases that come from, coal and natural gas. But it is very efficient, and it produces energy around the clock. And also, nuclear energy is so efficient that 28 grams of uranium produces the same amount of energy as 100 metric tons of coal. And that is only in the case of fission. There's two types of nuclear energy potential, and that is fusion and fission. Fission and fusion. Now, fission, it is from taking a big atom, such as uranium. It is a very heavy metal. It is one of the most heavy natural occurring elements on the periodic table. So what they do is they split it into two smaller atoms. And and that produces an overwhelming amount of energy that we harness and use to power our homes and our businesses and all that stuff. Now, fusion is a little different. It's a lot harder to replicate it to the point where we're going to produce it commercially, or people are going to be able to get enough output of fusion to create enough energy to power stuff. Now, fusion, here, lots of more advancements in technology need to be happening before we get to a point where we can really replicate fusion. But the upside to fusion is that it produces a lot more energy than fission. And it also cuts out a lot more waste. And in conclusion here, the most viable solution to the energy crisis would probably be nuclear energy, in my opinion. Advancements in nuclear technology would make it viable worldwide for people to use electricity and to harness it. Atomic energy is the way of the future, and right now we need to start.